For decades, industrial automation relied on analog, fixed-function machines performing rigid sequences. That baseline is rapidly changing today. The robotics sector is fully transitioning from programmed repetition toward intelligent, general-purpose physical AI. We can track this evolution across three distinct technological stages. Prior to 2010, the industry was defined by fixed-function SCARA robots. The subsequent 15 years introduced autonomous mobile robots navigating via SLAM. Now, entering the post-2025 window, we reach the integration of fully articulated physical AI and humanoid platforms. This progression forces a structural pivot in the value chain. Value generation no longer relies solely on single-purpose mechanical engineering. The advantage now belongs to integrated hardware-software ecosystems capable of continuous learning. Three specific technological breakthroughs drive this acceleration: dense computing via specialized AI chips, multimodal spatial sensor arrays, and vision language action models, or VLAs, which allow machines to observe a task, understand context, and generate the physical movement required to complete it. Robotic systems now act as physical vessels for artificial intelligence, operating autonomously within the real economy. In this architecture, artificial intelligence serves as the foundational product, while actuators provide the mechanical brawn at the base, and VLA models provide the cognitive brains at the top. Systemic autonomy is determined by the center layer, the embodied data moat. This chart breaks down unit installations for professional-use robots. We can see exactly where early adoption is generating the highest returns. Transportation and logistics dominate at 52% of the market, with professional cleaning securing a 13% share. This slide on medical robotics provides a proof point for high-stakes physical AI. Installations here grew by 91% overall, driven by a specific 106% jump in rehabilitation and non-invasive therapy robots. To capture this kind of growth across broader applications, companies require immense volumes of physical data. They are building proprietary value by recording real-world teleoperation and embodied human interactions, using that information to train large behavior models. Future market dominance will belong to the platform that amasses the deepest, most diverse embodied data moat, rather than the firm with the strongest mechanical hardware. Yet hardware scaling presents a physical bottleneck. The limiting factor in humanoid production is the manufacturing of high-precision actuators, the mechanical brawn that converts energy into motion. This map illustrates the geopolitical distribution of actuator production. Europe currently holds a 34% global market share, leveraging decades of precision engineering and automotive DNA, outpacing China at 26% and the US at just 5%. Compounding this geographical divide are contrasting strategic models. US firms generally favor closed architecture, vertically integrated systems to protect intellectual property and ensure reliability. Chinese manufacturers prioritize rapid, cost-efficient ecosystem iteration to deliver hardware at scale. Beyond hardware, there is an acute human capital constraint. Designing these systems requires a rare talent overlap, spanning generative software engineering and advanced mechanical kinematics. Consequently, aggregate capital flow within the sector is highly concentrated. Investment is directed toward physical AI research and massive manufacturing capacity, bypassing standard marketing expenditures. This establishes a high barrier to entry for pure software entrants. Without physical supply chain leverage and mechanical engineering talent, algorithms alone are insufficient to compete. Looking at the total addressable market, the projections are steep. From a $3 billion baseline in 2024, aggressive bull case scenarios model an expansion to $200 billion by 2035. The catalyst for this expansion is cost. As highlighted in this visual, the unit production costs for humanoids have decreased 30-fold over the past decade. This cost deflation is critical. By driving hardware prices below human wage thresholds, manufacturers unlock scalable profitability across commercial deployments. For labor-intensive industries, this triggers a macroeconomic transition. Corporate cost structures will begin shifting away from inflationary, recurring wage operating expenses and toward upfront, depreciable robotics capital expenditures. This shift dictates sector valuation multiples. Client valuations index against future market projections and automated productivity gains, rather than trailing hardware earnings. This pricing dynamic creates a distinct tech premium. Vertically integrated physical AI platforms command significantly higher multiples than legacy hardware manufacturers who lack proprietary control over the cognitive software layer. Humanoids introduce a new category of industrial asset, altering corporate balance sheets across the global economy. Deployment timelines face immediate headwinds. Impending global compliance strictures, led by frameworks like the EU AI Act, will dictate the pace at which these systems enter commercial spaces. Regulators are heavily focused on physical safety standards. In unstructured, dynamic environments, like hospitals or retail floors, widespread adoption will require mandatory human-in-the-loop oversight until autonomy is conclusively proven safe. The industry also carries supply chain vulnerabilities. Operating advanced VLA models requires uninterrupted access to massive AI computational infrastructure and cutting-edge silicon. Achieving commercial scale is contingent on more than technological capability. It requires navigating geopolitical semiconductor bottlenecks and evolving regulatory frameworks. Our institutional sector outlook is overweight. This rating is driven by the immediate convergence of declining hardware manufacturing costs and advancing vision language action models. Furthermore, we rate the sector's AI readiness as a primary beneficiary. Robotics companies with mature software stacks are positioned to absorb the productivity gains generated by the broader AI supercycle. Physical AI serves as a tangible manifestation of artificial intelligence. It transitions large language models from generating text on a screen to executing physical labor in the real economy. As these technologies move from research labs into mass-produced platforms, the window for early-stage capital allocation in foundational providers is tightening. Strategic capital must pivot now to capture the highest ROI nodes of this value chain before the physical infrastructure of the new economy is established.
My investment disclaimer. The content in this video is provided for educational and entertainment purposes only. It does not constitute financial, legal, or tax advice. The views expressed are my own and do not represent a solicitation to buy or sell any of the companies or assets discussed. Always perform your own due diligence or consult with a licensed professional before making investment decisions. Design your life, but stay safe. My